Okay, we're going to do some pre-calculus review concepts, and if you started your AP Calculus homework, we learned about, or we reviewed the order properties such as trichotomy, transitivity, addition and multiplication. Also, we looked at the commutative laws, associative laws, distributive laws, identity elements, and the inverses, which are all review, and you should have put those in your notes. Now, what we are going to look at is we're going to look at solving for specific variables. In this case, here is our example, and what we need to solve for is C. So we have abstract problems, and we're going to actually take this and use those properties to solve for C. So the first thing you want to do is you're going to multiply or distribute all the way through the V. Now, since you all know I'm not a fan of fractions, we are going to get rid of fractions. And the way to do that is multiply everything by XMC. And if we do that, we should be able to get rid of everything. So what I'm going to do is I'm going to put this in parentheses so that you know I'm going to multiply everything by XMC. So what I have here is Y times XMC equals VA over X times XMC plus B over MC times XMC. Now this is going to stay the same on the left, and what happens here is my X's go away, so I have VAMC plus MC and MC go away, so now I have BX equals YXMC. I need to solve for C, so what I'm going to do is I'm going to put the C's together. And now I'm going to factor out the C. So I could take the C, and now I have YXM minus VAM. And to solve for C, I have to divide both sides by this factor, YXM minus VAM. And that is the solution to our problem. So you could box it in. We have solved. We've used all the algebraic principles that we learned. Okay, again, we are solving some complex problems. This is not an equation, this is an expression. And what they want us to do on these, and we're going to attack A first, is simplify, which means we want to get rid of all the complex fractions. So we're going to take this in steps. Alright, the first thing I'm going to do is try and get a common denominator here. And by now, you should be able to take this and say D plus C over D. Now, before we do any kind of common denominator, we're going to try and get rid of this. And so we've got a complex fraction, and we're going to go A plus, stay, change this to a multiply, and flip. And I'm going to put this in parentheses so you know that the denominator is that whole thing. Now I need a common denominator between these two. So again, X, and it's going to be A times D plus C plus MD all over D plus C. Now I'm going to have this stay on top, change this to a multiply, and flip this fraction, which makes this D plus C all over A times D plus C plus MD. Now there's nothing that will cancel, so you can leave it like this, or you could distribute, and either answer is correct. You do not have to, as long as you can see that nothing else will cancel. Now, a common mistake is for students to cancel this. That is incorrect. You have a plus sign here. It is not a multiply, so you can't do that. So either one of these would be the answer. So now let's try for part B. Now again, we need to simplify these fractions. So we have an x squared and an x, so what I'm going to do is I'm going to multiply this by x over x, and so now I have a plus bx all over x squared. The whole thing is divided by, and I need a common denominator here, which means I'm going to multiply this by c over c and this by x over x. Let's put this up here so you see what I did. So now on the bottom I'm going to have cm plus kx all over x squared times c. Now I'm going to take this, a plus bx divided by x squared, change this to a multiply, and flip this whole thing. X squared c all over cm plus kx. Now, since these are factors, I can cancel and cancel. And when I do that, this is what I get. I could say c times a plus bx all over cm plus kx. That would work. Or I can distribute. You cannot cancel these because of this unforgiving plus sign. So now I could write ca plus cbx all over cm plus kx. All right, now we're going to talk about simplifying radicals. And if you recall, to simplify this radical, we want to get rid of this in the denominator. So what we're going to do is multiply it by its conjugate. And its conjugate is going to be, the first one stays the same, and the second one just changes to the opposite sign. And we don't want to change the value, so we are just changing the looks. And now we're going to distribute. 4 times 3 is 12. So that's first. Outer is 8 square root of 2. Inner is 3 square root of 2. And last is 2 times 2. All over the first, which is 9. The inner and outer cancel. That's why we use the conjugate. So we're going to have minus 4 times 2. 2 times 2 is 4, and square root of 2 times square root of 2 is 2. So now I have 12 plus 8 square root of, well, 8 and 3 is 11. So that's 11 square root of 2 plus 4 all over 9 minus 8, which is 1. So now I have 16 plus 11 square root of 2. And that's how we simplify that.